Hey, good morning, everybody. This is Mr. Aynesworth again, and we're going to get into a topic of how to graph cosine and sine functions with, quote, negative amplitudes, where the lead coefficient's negative. What does that do, and how do you graph it? And this is typically a little bit tougher than sine, because sine typically starts at the origin, untranslated. So it's a little bit easier here. We talked about that in a previous video, as you're taking a look at right here. So we're in part 3, graphing sine and cosine waves translated now, okay, but with negative lead coefficients or negative amplitudes. So we talked about how these are reflections, okay, over the wave axis or over the midline. So let's get in with some examples with cosine, because quite a few students are having difficulty. So let's go ahead and dive a little bit deeper. Before we do, though, I'm going to approach this a couple different ways. Everybody thinks differently, so I'm going to teach this 2 different ways. So what we need to do first before we get started is to screenshot this document right here, and then just copy and delete it. And we're going to put a second copy right off to the side of it, because I want to show you 2 different ways how to think about it. That way I can try to reach as many people as I can, because like I said, everybody thinks differently here. There's more than one way to do things typically. All right, so I am going to show 2 different ways. So notice that I just put that off to the side for method number 2. Also, this one here as well, just go ahead and press and hold on this next page, copy it, okay, and then go over off to the side, press and hold, and copy this one or paste this one here too. So notice we have 2 copies of the same document, so we can do it 2 different ways. Okay, so here we go. All right, the first basic way to graph negative cosine x, which is the parent function but with a lead coefficient negative, is to obviously plot some points, okay, from 0 to 2 pi. As we know, cosine has a period of 2 pi. This one does too. It's just a reflection of the other parent, which you should all have memorized. So the first basic way to graph a function, to learn about it, is to simply plug in values. All right, you're going to take your angle here, all right, your angle, and you're going to substitute it in. And then evaluate. This is your first most basic way when you're learning. So here I have negative cosine of 0. And then here you have to understand the unit circle and the values. So that's pre-skill. We studied that a couple weeks ago, and so you got to be good at that. Cosine of 0 is 1, all right, but then you got to make it negative. So you're going to have negative 1. All right, next one, negative cosine of pi halves. Now you're at the top of the unit circle where the x-coordinate's 0, so negative 0 is 0. Then you have cosine of pi. Now you're on the left side of the unit circle, half revolution around there. Next x-coordinate is negative 1. That means you have a negative of a negative 1, which is a positive 1. Okay, next one, we have a negative cosine of 3 halves pi, and now you're at the bottom of the unit circle. Again, you just got to visualize where you're at. You got a circle here, right? 3 halves pi is at the bottom, so it goes 0. Pi halves at the top. Pi is on the left side, and then 3 halves pi is on the bottom. X-coordinate's negative there, 0 there, and you have 0. Negative 0 is typically 0, especially at 5 o'clock in the morning. And then, it's early, guys. Okay, and then you have negative cosine of 2 pi, and that's back to negative 1. So let's go ahead and scale the axes like we always do. We're going to go up 1, down 1. You can plot this wherever you want. Just make sure you go equal units above and below. Period of 2 pi, so go out either 4 or 8 units. I'm going to go out 8, just kind of stretch it out a little bit. Easier to graph and see. So 2, 4, 6, 8. Label that 2 pi. Okay, that's your x-axis. All right, and so here we go. So 0, negative 1 is obviously down here at 1. And then pi halves come at 0. Oh, let me label. Hang on. So this is pi, this is pi halves. Got to label. You got to be able to see these angles here. So put all the angles in, and now go for it. Okay, so here we go. 0, negative 1 is down 1. And then we have pi halves come at 0, back to the wave axis. Okay, so the x-axis here is the wave axis. Because it's not translated, there's no shift. Okay, so no shift on this one. And let me see, pi comma 1. So we're going to go right pi radians and up 1, and then 3/2 pi comma 0 back to the wave axis, and then 2 pi comma negative 1. Okay, so this, and then you curve it. Okay, you curve it. And there you go. This is negative cosine x. So negative cosine x. Now that's one way to do it, is by plotting points. Okay, the other way to do it is to graph cosine first and then reflect it. Because this right here, this negative right here, is a reflection across the wave axis. Now I have to say reflection across the wave axis and not the x-axis, because when you shift something, though, your wave axis changes. So you always reflect it, okay, across, okay, the wave axis in general, because that may change depending on the function. So let's say wave axis here, and of course every time I say wave axis, I'm referring to the midline, as that's more modern terminology. Back in the day when I was young, okay, I was taught wave axis, right? But now over time, people have changed the terminology here, and people call it now the midline. Midline meaning it's the average value, or it's the line going right through the middle of the wave, okay, midline or wave axis. Okay, so now the other way to do it, okay, is to simply graph cosine first. And so you have to have all your parent functions really memorized here. So I'm just going to graph the parent function cosine in red. Okay, so cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is negative 1, and then cosine of 3/2 pi is 0, cosine of 2 pi is 1, and then you graph it. So I'm graphing here in red, all right, the cosine function, the first parent that we graphed a long time ago. So notice this is cosine x. So what you could do is graph the other parent and then reflect it, okay? So you could do that. Okay, so reflect. That's method number 2. And then again, if it's pi comma negative 1, and then you reflect it, it goes above the wave axis. Reflect. And then, of course, reflect. Okay, so you guys have to understand that the negative right here reflects across the wave axis. So you can plot the parent function and then reflect. Okay, so plot parent function. Okay, and then reflect. So that is method number 2 right there. You can plot it by points. That's method number 1. Just flat out put some angles in there and graph the function. Although most experienced people don't do that. All right, you get used to the patterns, and you see that you memorize your parent. And then most people, when you get experience, just plot the parent function or visualize the parent function and then reflect it in their mind. Okay, that's how I do it. All right, now let's apply it here, okay? So, example 13, here we go. The first thing we need to do is analyze, okay? So let's do that. So we have the general function here. I'm going to write it at the top. Y is equal to a times cosine of bx. All right, that is for this function here. The most general function is y is equal to a times the cosine of b times x minus h, okay, plus k, where you have a shift, okay, which is h comma k. You have some horizontal shift and then a vertical shift. So if you add or subtract something from the x coordinate, which is your angle, your input value, which is your angle, okay, this is going to be a horizontal shift. And if you add something to the function, add or subtract something, that's going to be a vertical shift. And here we're not doing either one of them. All right, so there's no shift. No shift. You can put down 0, 0, I guess, because there's no shift. And then a is negative 3. All right, and then b is pi half. So here we go. Let's get to work. So amplitude is always the absolute value of a. So we're going to take the absolute value of 3 to get 3. And the reason why we take the absolute value of it is because distance is always positive. Distance always positive. Okay. And that's why we take the absolute value of it. So be careful there. But this right here, we have a negative. Now, when a is negative, you have a reflection. Okay, so I'm going to say the amplitude is 3 with a reflection. Why? Because of this, okay, that lead negative right there. So when you see that lead coefficient negative, you got a reflection across, okay, the wave axis. So always write down the wave axis first because it may change depending on the problem. Like in the next example here, we got a shift. So the wave axis is not the x-axis, okay? So it's always reflected across the wave axis. All right, so now the period, what's the period? Well, period is 2 pi divided by b in general. B is pi halves. So what we're going to do is we're going to take 2 pi divided by pi halves. Okay, back to grade school, multiply by the reciprocal. So we're going to take 2 pi times the reciprocal pi halves, which is 2 divided by pi. So you multiply by the reciprocal. Simplify a little bit. Pi divided by pi is 1. All right, and then you'll notice you have 2 times 2, which is 4 units. So this thing repeats every 4 units. There's no shift, and the wave axis here, or your midline, okay, in general, is always y equals k on your shift. K is 0. So we have midline at y equals 0, which happens to be your x-axis. Okay, so the wave axis, or this thing is going to be reflected across the x-axis here. All right, so what we do is we label the axes first. So let's go ahead and do that. The wave axis is the x-axis. Our amplitude is 3, so I'm going to go up 3, down 3. Okay, so we're going to go up 3 using the amplitude because A is 3. We're going to go down 3 units, mark that. A is 3 here. And so the wave has to oscillate between these 2 dotted lines. Okay. You don't have to draw these. It's just a guide. It helps everybody visually. So I always draw those. The wave axis is your x-axis. And now we go for it. All right, so method number 1 is this. What we're going to do is we're going to start off, this is a cosine function. So it starts off on the y-axis typically at 3 with the amplitude of 3. So typically it would start here at 0, 3 if it had an amplitude of positive 3. However, there is a reflection, right? Because of the negative right here. So what we're going to do is plot that, but then reflect it. Okay, so I'm going to reflect it. Actually, yeah. Okay, so we're going to plot that, and then I'm going to reflect it. So now I'm actually going to start here. So if A was positive 3, I would start at 0, 3. But it's negative, so you got to reflect it. So it starts here at 0, -3. And then, of course, you got to go out 4 units. So count out 4 units to the right, starting, at the start point, just count 4 units to the right. 1, 2, 3, 4. That's where you're going to end it. Okay, so what we're going to do is we're going to plot the other 5 points. So we always plot 5 points. So this function here starts here, and it's going to go up to the wave axis, and then to a maximum, back to the wave axis, and down to a minimum. And then you curve it. Oops. Let me draw that a little bit better. So here with the wave axis, hits that max, and then comes back down. And again, these are not straight lines, these are curves. And there we go. That's one way to graph this function. And then, of course, you got to check it, right? So let's do this. It's always kind of nice to know if you're right. So let's prove or find out if we're right. Okay, so hopefully I'm right. So y equals a -3, right, times the cosine to cosine. I love Desmos, okay? So always check your graphs with Desmos. Of course, you can go into Canvas and use my instructor's notes, but hey, this is kind of nice to know how to check it on your own. So notice what we have here. So I'm just going to plot the points that we're looking at here. There we go. Let me just adjust it. So notice that it starts here at 0, -3, just like I showed you. Hits at 1, 0. Goes up to the top at 2, 3. And if you look on the left side here, you'll notice that this maximum occurs 2 units to the right and 3 up. This is 1, 0. Down here, this is 0, -3. and then 1, 2, 3. This is 3 comma 0, and then this is 4 comma negative 3, 4 comma negative 3. So if you check on Desmos here, you'll notice that they have the same points. Okay, so let's screenshot this and just bring this in, just to show that you guys that we're right here. Let's bring this function in. There we go. So it's pretty cool, pretty handy to have a tool like Desmos to show that you're right, or to find out if you're right. So let's just paste this in, just hit the text box, press and hold somewhere. Come on. Let me find. You gotta press and hold in a free spot here, meaning where there's no document. At least that's what I found on the iPad. All right, so there you go. It looks a little crazy right here, but let's just put it right in through here. Ah. Give me a second. I don't know why it's taking a while. Hang on. Okay, so we got this function. Come on. Give me a second here, guys. This is working with technology is always a challenge a little bit. There we go. All right, so now you see that with Desmos, the same thing. So let me highlight the portion of the graph that you guys should be looking at. So right through here in blue, right there. Okay, that's the same. All right, and remember, we're using Desmos here. You can check it with the TID4 as well, okay? All right, that's one method to do it. So here's the other way. Okay, so let's go off to the side and let's do it one more time. But again, I'm trying to reach everybody and show you that there's different ways of thinking here. So here we go. So A is negative 3, B is pi halves. Got the same situation. Okay, so we get the absolute value of negative 3 is 3. The period, as we know, is 2 pi divided by pi halves, which is 4. No shift, okay, and the wave axis is 0. So here's the other way you can do it. So let me go up 3, down 3, and plot. Okay, so that doesn't change. Okay, so what you could do is pretend A is positive 3 and plot the function. Okay, so that's what I'm going to do. I'm going to graph 3, or y equals 3 cosine of pi halves. So pi halves x, I'm going to graph that and then reflect. Okay, so here we go. So we're going to start off with the amplitude at 3. So this one starts at 3 right here. I'm going to go out 4 units and mark it here, just like I did over here, okay? And then what I'm going to do is I'm going to graph this function, and then I'm going to reflect each point. So I start at 0, 3, so I'm going to start up here. And then I go down to the wave axis, down to a minimum, back up to the wave axis, and then up here at a max. So cosine, as you guys know, starts off at a max and ends at a max. That's how the parent function works. If you go back to your notes, okay? So I'm going to graph this function. There we go. So this right here is cosine, not cosine. That's 3 cosine of pi halves x. That's the one in purple. So we graph that first. Okay? Now reflect each point. So 0, 3 gets reflected down here at the bottom. So I'm going to switch to red. And then 1, 0 doesn't move because it's on the axis. Okay, the minimum becomes a maximum. So the maximum becomes a minimum. The minimum becomes a maximum. So you reflect it. Okay, and then your max becomes the minimum. So here we go in red. Here's the reflection. So now I'm just plotting the parent function, assuming 3 is positive, and now you get then you reflect it. So this is negative 3 cosine pi halves x. So there's 2 ways to think about it here. So you could graph this one first and then reflect it, or you can do it the way I did earlier in the beginning. You can just reflect immediately. Okay, I do it the first method here, but this may be good or might make more sense to you guys if you do it this way. So you decide which way makes more sense. Okay, all right, now let's do a shift. All right, I'm going to do it the way I do it first, and then I'll show a different way. All right, so let's see here. So we've got to solve for y. It looks like our y is already solved. The general form is y is equal to cosine b times x minus h, okay, not plus h, but minus h plus k. You got to be careful here on this one. A is -2. All right, absolute value of -2 is 2, but this is with a reflection. With a reflection across the wave axis. We'll determine the wave axis here in a minute. Okay, the period, all right, is 2 pi divided by b in general. So this is 2 pi divided by pi force. You multiply by the reciprocal. So 2 pi times 4 over pi. The pi's cancel, right? Pi divided by pi is usually 1. So this baby has an amplitude of, a period of 8. 2 times 4 is usually 8. Now there's a shift here. Now we got to be careful. Inside here, this is x plus 2, but the general form states that h is found by whatever number is being subtracted from x, right? And we know that x plus 2 is the same thing as x minus a -2. So h here is -2, not +2. So you got to be very careful here. We have a shift of -2, which is a left shift, all right? And then the k is 2. K value is 2, so we're going to go left shift up 2, okay? So left 2, up 2. Most common mistake people see is they just see a 2 there and they put 2 comma 2. Okay, so when you add something to x, that's a horizontal left shift. And if you subtract something from x, well, guess what? That's a right shift. I guess that's counterintuitive. But anyways, that's how it works. So now the wave axis here, y equals k. K is 2 now. So we have a wave axis at 2. And again, that is called the midline for all you modern people. Okay, and so now here we go. So let's set up the axes here. You got to label first. See, we got an amplitude of 2 and a wave axis of 2. So I would graph the wave axis first because we have a shift. So graph first. So here we go. So at 2, we have the wave axis, the midline. All right, from there, we use the amplitude. Okay, so we're going to go up 2, down 2 from the wave axis. Okay, so up 2, down 2 from the wave axis. So we're going to go up to 4, down to 0. So we're going to go, again, this distance is called the amplitude, okay, from the wave axis when A is 2. So let's draw our guiding lines here. Okay, so the wave has to oscillate through here. Okie dokie. So let's see what we have. Okay, now, so what we're going to do is we're going to use the amplitude. So let me switch colors here so you can see better. So on this one here, a cosine function with an amplitude of 2 typically would start right here, okay, at 0, 2. But this baby's been shifted, okay, as I was saying. Let me erase this. I got to draw some things here. Okay. So typically it would start at 0, 2, but there's a shift, left 2, up 2. So we're going to shift it, left 2, okay, up 2. There's your shift. Okay. So I'm going to shift and reflect. Well, I got to put a graph in there. I better not write that here. Let me just write it, my thinking up here. So shift and reflect. This is method number 1 now. So I go left 2, up 2, plot a point, but you got to reflect it because A is not positive 2, it's -2. So this cosine function does not start at -2, 4. You got to reflect it, okay? So reflect it, so it really starts here. Okay, so you move 8 units to the right. Okay, so from here, you count 8 units right from the start point. So count 8 units I'm having a hard time writing here. So count 8 units from the start point. So 1, 2, 3, let's just count by twos. 2, 4, 6, 8, mark it. So I end it here. I can't write this morning. God, it's too early in the morning, guys. I shouldn't be doing videos at 5 o'clock in the morning. Okay, so here's the period from here all the way to here. Period is 8, right? We're at -2, and then we go to 6, right? There's 6 right here. Okay, just count 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it starts at -2, ends at 6, period length 8. We're good to go. So we're going to mark off, we're going to divide that into 4 equal parts. 1, 2, actually I'm going to do it up here. So mark off 4 equal parts, and then we're good to go. So here we go. We're starting at, it looks like -2 comma 0. Then we go up to the wave axis, which is at 0 comma 2. Then to a max, back to the wave axis, and then end it. So here we go. Let's curve it. There we go. That's one way you can do it. You could shift the start point and then reflect it and then go ahead and graph it. Okay, and there's another way. You can pretend it's +2, graph the function, and then plot, reflect every single point. So whatever makes more sense to you. So I'm going to do it one more time, and let's see if I can get you to understand. Okay, so here we go. Let's go off to the side and do it a slightly different way. So the amplitude stays the same. So same information here. We got a amplitude of 2. We got a period of 8. We have a shift of -2 comma 2. And we have a y-axis or wave axis at 2. Okay, so that doesn't change. So draw the wave axis first. Draw your guiding lines, go up 2. And go down 2. Okay, so it's got to oscillate here because it's got to go above and below the wave axis 2 units. Okay, so now what I'm going to do, here's the difference here. So I'm going to pretend A is +2, so I'm going to graph this function first. Okay, so I'm going to graph this function. This one right here would typically start at 2 on the y-axis right here. So I'm going to mark 2, but I'm going to shift it. I'm going to go left 2, up 2, so I'm going to start up here. So this is my start point. If A is positive, so then I'm going to go 8 units to the right and mark it. So 2, 4, 6, 8. So I'm going to start at a max. We all know that cosine functions start at a max, and we end at a max. Okay, so here we go. So you go 2 units to the right and down on the wave axis. Then go another 1/4 of the way, go down to a minimum, back to the wave axis, and then to a max. So here is the function with no reflection. That's this one right here. Then what you do is you reflect every point across the wave axis. So I'm going to do that in red. So we're going to reflect here. We'll write down the word reflect. So you reflect every single point across the wave axis. So reflect across wave axis, not the x-axis, the wave axis. Okay, so this point here at -2 comma 4 gets reflected down to -2 comma 0. Okay, on the wave axis, 0 comma 2, that point does not change or does not move because it's on the wave axis. Your minimum down here at 2, well, guess what? That gets reflected up here. So it gets reflected, it becomes a max. Okay, so your max becomes the min. Your min becomes the max. And then you're at the wave axis, that doesn't move. And then this max becomes a minimum. Okay, because it gets reflected across the wave axis. And then you draw your function. So here we go. Oop. Trying to put the sound effects in. There we go. And notice that's the same as what I have over here. Okay, different color, but the same thing. Okay, so the one in red is the actual function. Y is equal to negative 2 cosine of pi fourths of x plus 2, and then plus 2. So you have two options in graphing here. You can pretend it's the lead coefficient is positive, go ahead and graph it, and then reflect every single point across the wave axis. Or you can do what I usually do, is I just shift it and then reflect it. All right, so whatever makes sense to you guys just go with the flow. All right, now just for funsies here, I'm just going to do one more and just switch to sine. Sine's easier typically, but I would just want to do one more and just kind of change the thought process. Okay, so here we go. We're going to take A here, and B is 1 because there's no coefficient. There's no shift on this one, so no shift. So the absolute value of negative 4 is 4. Period is 2 pi divided by b. So b is 1. So 2 pi divided by 1 is just 2 pi. I don't see anything subtracted or added to the function, so there's no shift. All right, so you can write down 0, 0 if you want, and then y equals 0, or your x-axis becomes your wave axis. Okay, so your midline. So here we go. So I'm going to go up 4, down 4. So go up 4, down 4, draw your guiding lines. Okay, it has to oscillate in between here. Sine, untranslated sine function starts as the origin here. So that's your start point. Sine always does that if it's not translated. That's why it's typically easier to graph. Okay, and usually, if you remember your basic parent function here, if you remember the parent sine of x, typically, you guys know that it has an up-down cycle. So it goes up first, and then down, then back to the wave axis. This is the parent. All right, well, this one gets, this is reflected here. So this little negative right here, all right, this is a reflection, okay, across the wave axis. Or across the midline, which happens to be the x-axis here. Okay, so instead of having an up-down cycle, it's going to be the opposite of that. So instead of going up and then down, we're going to go down then up. We've got to graph 2 pi though, so let's mark off. There's pi, pi halves, pi, 3 halves pi, 2 pi. You have to graph that first because I need to know where 2 pi is. Divide it up into 4 equal parts as we always do and start your graphing. Okay, so instead of going up to pi halves comma 4, we're going to go down to 4. So it's got this down up cycle. And then a pi comma 0, and then 3 halves pi comma 4, okay? And then back to the axis right here. So when you graph this bad boy, it goes down, and then back up to the wave axis, and then to a max, and then back down here. And then, of course, let's check it just one last time, just kicking a little Desmos action here. And let's see if we're right. So turn off your color, type the function in. So y equals negative sine. Okay, negative 4, excuse me. Let me put a 4 in there, sorry. So negative 4 sine of x. Okay, and there we go. So then you plot a couple points, and you see if you're right. And then over here on the left here, let me just label a couple points. So this point down here is pi halves comma negative 4, which is the same on Desmos over here on the right. I mean, we're at pi comma 0, and 3 halves pi comma 4, and then back at 2 pi comma 0. So you can see that this is the same graph. And that's all there is to it, my friends. All you have to do is get some experience, which means you got to do your homework, all right, and get some practice, because one example does not enough. And I'm looking at number 16 here. Ooh, that has a shift. Let's do one more. Okay, so here we go. Let's just do one more for funsies right now. If you want to stop the video, go ahead. If you need it, keep it running. All right, or pause and play it. Try it and then check it. That's what I would suggest. Okay, so in this one here, we got A is 3, the general form is y is equal to a times the cosine of b times x minus h plus k. So this right here, this is actually the same as x minus a negative 3 halves pi. So h is negative 3 halves pi. So you gotta be careful there. So a is 3, absolute value 3 is 3. Period. B is 1 right here, so it's 2 pi divided by b, or 2 pi divided by 1, or 2 pi. So the period's 2 pi. We have a shift here. It's negative 3 halves pi, comma 0. There's no k value, all right? K is 0 there, so this is a left shift. And then the wave axis is the x-axis here. Okay, the midline. All right, so here we go. So let's graph here. So let's plot your axes. So let's go up 3, down 3. Using the amplitude, we have... oh, you know what? This is going to... we have to shift 1.5 pi to the left. We're going to be off the grid. Okay, so here we're going to have to adjust this because this is the wrong... This setup here is no good. So here, let's erase this, and let's redraw the y-axis. Let's put the y-axis over here somewhere. Okay, so I'm going to redraw this one here. So now we have a y-axis here, x-axis here. So ignore the other one, and now let's graph. So I'm going to go up 3, down 3, and then we got to shift this. So we're going to have to plot this here. So let's say we have negative pi halves here, negative pi, negative 3 halves pi. Over here on the right, we have pi halves. Okay, so here there was a left shift of 1.5 pi. So I had to redraw the y-axis because otherwise we'd be off the grid. Okay, so now at this point here, let's see. We got a shift. So normally it would start, normally it would start at 3 units right here. So let me plot it. Normally it would start there, but we got to shift this bad boy. All right, and then graph, okay? So we got to shift first. Okay, so shift the start point. So we're going to go left 3.5, 3 halves pi units, and then start your graphing. So that means you just got to go shift. Okay, so now I'm going to start here. There we go. All right, and then our period is 2 pi. So well, I'm a little bit off right there. So let me change that. I went a little too far. Okay, so right here, and let me draw my guiding lines here. Okay, so shift 3.5, 3 halves pi units to the left. That becomes here. So this is my start point. And then I got to go 2 pi radians to the right. So let me see, I got to count 4. Okay, here we go. So this is my end point right here at another max. Start at 1 max, end at another max. There's no reflection here. So no reflection. So period length is 2 pi. So let me show you what I was thinking here. So this is period length 2 pi. Okay, so from negative 3 halves pi to pi halves is 2 pi radians. Okay, so here we go. We're going to plot the first point. We start there, then go to the wave axis. Again, the wave axis is the x-axis. Down to a minimum, back to the wave axis, and then end at a max. So we start at a max, we end at a max. So here we go. There we go. Now we better check this one, okay? So check this out. Let's go bring in decimals one last time. All right, and let's check our graphing here. So turn off the other one, and let's plot this one. So y is equal to 3 cosine, okay, of x plus 3 pi over 2. All right, and let's see if we were right. So let me expand this. We're gonna have to switch to radio mode. Let's watch this. Click on the wrench, and let's adjust the x-axis from negative I'm going to go to negative 2 pi to pi. And your step, okay, your step has to be pi halves because we're counting by pi halves, so pi divided by 2. Let's see how it looks. There we go. Okay, so let's see. That looks a little bit better. There we go. So starting here, let's plot some points. So notice, yeah, there we go. So notice we start at negative 3 halves pi comma 3. We hit the wave axis here, go down to a minimum, goes through the origin, and then at pi halves comma 3. So let's screenshot this and let's compare this to what we have in our OneNote. All right, so let's copy and delete this guy. Let's bring it into our lesson here and let's check it out. So I'm going to bring it in. Got to click on the text box on your iPad here, press and hold down on some free space and wait for the paste command to come in. And then boom, we can check it. All right, so let's check it. Let's see if we're right. So let me highlight it. So we're looking at this piece, this portion here. This is one period only. All right, so here we go. There's the portion here. So notice and compare, they should be the same. All right, so over here on the left side in our OneNote here, we started at negative 3 pi halves comma 3. So negative 3 pi halves comma 3. That's where we started. We go down to a minimum, and that looks like negative pi halves comma negative 3. That's the same as Desmos here. So again, I'm comparing. And then it goes to the origin, 0, 0. And then it ends at a max. And that max looks like pi halves comma 3. So pi halves comma 3. There we go. And that is all, okay? So we verified it. So check by plotting points. Check Desmos, plot the points, compare, and you're good to go. All right, and that's how you do it, guys. The only thing you got to do is practice and get good. Hopefully that helped you out. All right, this is Mr. Aynesworth, and I'll see you in class. Take care.